Let's start our presentation. They are all our contents. And firstly, we will introduce model requirement. In today's fast-changing world, people need better ways to manage their times. Our all-in-one personal assistant uses large language models to help organize schedules intelligently. By understanding what users need, it makes it easier to balance tasks and stay productive.
Okay, so in this part, we use feature diagram to represent the hierarchical organization of features in our system, showing optional, mandatory, and alternative features to capture variability. As you can see, there are some features and one optional features. For task management part, the system will help user improve efficiency by breaking down tasks and automatically setting priorities. For word learning part, the system will assist user in learning and memorizing words through the forgetting curve, word stories, and customized tests. For email assistant part, the system will intelligently summarize the email content, analyze emails, and add events to the schedule, helping users manage their emails. For travel recommendation part, the system will provide personalized travel recommendation based on the user location and travel plans, generating a specific schedule. For emotional cognition part, the system will adjust task allocation strategies based on emotional analysis, offering emotional support to help user cope with stress. For note-taking part, the system will intelligently generate lecture summaries, integrate notes, and send study reminders to help users manage their notes. For peer summary part, the system will intelligently generate peer summary reports to help user manage and review their progress. Okay, so let's go to the next part.
This use case diagram shows how users interact with various system functionalities. Users manage tasks with smart task management, which includes task decomposition and emotional state-based allocation. They can also use dynamic time allocation and routine optimization. The system provides award learning modules, LLM-generated emails, travel recommendations, note-taking, emotion recognition, and summarization, all aimed at enhancing user productivity and personalization. Let's move to the showcase part.
Okay, I will give a briefly showcase. The use case specification diagram clearly visualizes how stakeholders communicate by modeling system behavior. It identifies the actors involved and their interactions. For example, this user login diagram illustrates a user login scenarios, showing how users interact with the system during the login process. Okay, let's move to the next part.
Yes, the ad hoc diagram outlines the entire project, highlighting 7 main functions in the yellow box. Users can access this function via the UI. Next slide, please. Here are 3 examples. When an email is received, if the user authorizes their email, a large language model generates a reply, extract keywords, and schedule tasks. The travel recommender suggests a destination using the large language-based insights, while the report summary provides an overview of the user's completed tasks. Let's go to the class diagram.
For the class diagram part, class diagrams provide a clear representation of the system's architecture, showing the classes, their attributes, methods, and relationships. In the model-based engineering field, class diagrams help maintain traceability by linking system requirements to specific classes and their interactions. For our class diagram part, we use a centralized core controller, which you can see that, to control users and their schedules.
We use object diagram to show how class and object in the system interact from an instantiation point of view. In this system, a user object has a schedule which contains several different types of events, such as email events, travel event, emotional support event, and so on. Each event object records detailed information, including the time, location, state of the event. In addition, the user associates a course which contains multiple lectures and a vocabulary book which contains multiple words. User can record personal summary to check behavior and analyze over time. Overall, the object diagram clearly shows the interrelationship between the objects, reflecting the dynamic structure and the information interaction of the system. Let's go to the package diagram.
In our package diagram, we use a star topology and we organize the system into several functional modules. At the top, we have user management, which handles login, registration, and profile management, all connected to a central database. Task management includes features like smart task management and dynamic time allocation. In the word learning package, we see components such as importing words and the forgetting curve-based reminder system. The email assistant integrates LLM-generated emails with email content analysis and event integration. Several recommendations, note-taking, and emotion assistance are all supported by the central LLM, which powers many of the system's advanced features. Finally, monthly and yearly summaries are generated to give users insights into their productivity. Let's go to the next part.
Okay, so in this part, we use deployment diagram to visualize the physical deployment of software, illustrating how system components are distributed across servers or devices. As you can see, the execution environment of this system can be Windows or Linux. The user can launch our application by executing the JavaScript file on web browser. The application can communicate with the backend web server through HTTP protocol. Besides, we use Spring Boot as our backend web server. The prompt XML is the deployment specification file, which specifies the parameters that guiding the deployment of the jar file. The jar file has manifested the relationships between the corresponding components. The web server will connect with the database server by using TCP/IP protocol, and will launch MySQL database service as our local database. Inside, there are several schemas of our database. Okay, so let's go to the next part.
This is the behavioral part. Next page, please. We use activity diagram to capture the sequential and logic of system process modeling behavior. This diagram outlines the vocabulary learning process. The user opens a learning page. The system checks for an existing vocabulary base and import one if necessary. User can learn new word or reveal old one, with the system recording word based on the memory code. LLM generate related short story and text question during the learning. Finally, feedback and analysis are provided to understand the progress and complete the learning process. Let's go to the sequential diagram.
The sequential diagram shows the time-based interaction between the user and emotion support. When a user begins chatting, their input is processed by the larger language model, which work with the database and task manager models. In case of severe and mild stress, the system adjusts the task allocation accordingly. Let's go to the next part.
So in this part, we use state machine diagram to model the dynamic behavior of a system by showing the different states and operators and transitions between those states. I use note-taking as an example to explain. First, when a user uploads a file, the system transitions from an idle state to a file present state. After that, there are two possible outcomes. Either the file is valid or it is invalid. After generating the summary, the system sends to the notes and saves it, enter the note save state. Then the system sets the reminder time, moves to the reminder schedule state, and finally ends the process. Okay, so let's go to the next part.
In our project, change assessment involves evaluating the impact on system performance and stability, analyzing dependencies between modules, and considering development costs and time. If the change passes performance tests and risk evaluations, it is accepted and processed to development. If it possesses significant risks or has high costs with limited benefits, it may be rejected or postponed. This ensures stable and efficient system development. That's all of our presentation. Thank you.